Hi, this is Alex from devstories.eu. High Performance Python Async, Episode 6 of 17. You query a database for a user record and get a raw string back. Every single time, you write the same boilerplate code to parse that string into a dictionary before you can actually use the data. You can teach your database driver to speak your application data format natively, saving you from manual parsing on every query. This is done using custom type codecs. When you query PostgreSQL using the driver, basic types like integers and text are translated automatically. But when you use rich database types like JSON, the driver needs to know how you want that data represented in Python. A custom type codec acts as a translation layer. It sits between the database connection and your application logic. To configure this, you use a method called setTypeCodec. You call this method directly on an active connection object. It requires four main pieces of information. First, you provide the name of the database type, such as the string JSONB. Second, you specify the schema where this type lives. For built-in PostgreSQL types, this is the PG catalog schema. Next, you provide the translation logic by passing an encoder function and a decoder function. The encoder defines how Python sends data to the database. It takes your Python object and returns a format PostgreSQL understands, typically a string. If you are working with JSON, you can simply pass the standard library JSONDumps function. The decoder defines how data comes back from the database. It receives the raw string from PostgreSQL and returns your desired Python object. For JSON, you just pass the JSONLoads function. Consider a system storing unstructured user preferences. In your database, the preferences column is defined as JSONB. In your Python application, you handle preferences as a standard dictionary. Once your codec is configured, you execute a basic select query for a user. The preferences column arrives in your application already structured as a Python dictionary. When you run an insert query, you pass a dictionary directly as a query argument. The driver automatically triggers your encoder, converts the dictionary to JSON, and sends it to the database. You never call an encoder or decoder manually in your query execution code. Here is the key insight. Custom type codecs do not apply globally to the entire database driver. The setTypeCodec method only modifies the specific connection it is called on. If you configure a codec on one connection, a second connection will know nothing about it and will return raw strings again. This behavior frequently causes problems when developers introduce a connection pool. You cannot configure a pool with a single codec method call. Instead, you must register your custom codec every time a new connection is established. You achieve this by defining an initialization function. Inside that function, you accept the new connection object and call setTypeCodec on it. You then pass this initialization function to your pool creation logic. The pool runs your function automatically whenever it opens a fresh connection, guaranteeing your codecs are always present and active. Pushing data serialization down into the driver layer through custom type codecs removes repetitive parsing logic and ensures your data formats remain perfectly synchronized across your entire application. Thanks for listening. Happy coding, everyone!